Assalamu alaikum. In this video, I'll be explaining my microcontroller and embedded systems project, which was a line follower robot with 6 IR sensors and had an LCD, and which was used to display the voltage and current readings and the distance which was being traveled by the robot, and also had an SD card connected with it, which stored the path on which the robot had traveled. So first of all, the first part of it was to create a block diagram. So in my project, in my line following robot, I used two Arduino Unos. So here in this here on the screen, we can see that in the block diagram we have this first Arduino Uno, which was basically used to basically sense the line, and if there is any object in front of us, and move the robot accordingly. So the motor driver and the left and right motors were attached to this Arduino Uno. We made a two-wheel robot or three-wheel robot. So two of the back wheels were used for the controlling of the robot, and the front was a free wheel. So the motor driver was attached to the first Arduino Uno with two motors, and then 6 IR sensors were attached to this Arduino Uno, and then the ultrasonic sensor. So here we can see the inputs of the 6 IR sensor, the enable of the motor driver, and the inputs of the motor drivers, and then the motors, and then the ultrasonics, trigger, and echo pins here. And so the second Arduino Uno was used for the whole interfacing, in which we had the current sensor, voltage sensor, a tachometer to keep the distance track, and then the LCD and the SD card module. So we basically made this project in two phases. First, we made it on Arduino IDE. We coded it on Arduino IDE. So in which we operated the LCD using a I2C converter, and in that module the SD card was connected to the on the first Arduino Uno, where the motor drivers or the motors were and when we created the code with the C language, we shifted the SD card module to the second Arduino Uno, because we were not able to use the I2C using the C language, C programming. So SD card had to be shipped here, and we had to do the serial communication between these two Arduino Unos to store data in the SD card module. So after looking at the block diagram, let's move towards the design. So now let's move towards the code. So first, before the code, we made this Proteus simulation. So this is the simulation for the motor first Arduino Uno 1, in which here we have the motor driver and the IR sensors here, and the motors connected here, and everything. And we are testing in here. We tested out our code, the line following code. So first, let's review the Arduino Uno code, and then we will come to the C code. So first is the code in the Arduino IDE. We can see here we have defined all the pins here. All the analog pins are the sensor pins, where we are getting input from the sensors, and here we have included the motor library. Okay, and so there are the library has pre-built functions of setting the speed and setting the, here we can see in the first of all, and here we have also labeled the motors, the front, right, left front, and left back, and right back for the Arduino IDE, which was basically built on the breadboard. So for that we used 4 motors. Our design had 4 motors, and for the 3 motor design was used for the C language programming. So here we have 4 motors. If we have defined them, given them names, right front, left back, and right back. And in the setup we can see we have first set their speeds, and declared all the analog pins as the inputs, and in the loop we have simply here we have we have created if conditions on which based on our logic or our truth table, according to which the line following robot will move. So all the conditions, like if the robot senses that the line is on the center and the right center IR, then we will turn right, and if similarly if the left sensor senses it, then we will turn left. So similarly all the logic that we had created in the truth table, we have created this code accordingly. We have created all the if conditions, and accordingly give the we have used the here we can see these run functions. These basically the release function stops the motors, and if you want to go forward we can write the name of the motor and then .run, and then write forward in it. If you want to move it backwards you can move backward, and we can, if you want to stop it, we can use release command. So all of these commands and all of these conditions are created accordingly how we want to move our line following robot. So let me just show this example here, show you this example on like here, if digital read 1 and digital read 2 and digital read 3 and 4 and 5 and 6, which means that if all of these are 1, so what will which means that all the sensors 1 2 3 4 5 and 6, these are all the 6 sensors. All the sensors read 1, then we have our output will be that the robot will not move, it will stay onto its position, and 1 means that there's a white line. Now here if our digital read with 1 2 3 4 5 and 6, all of these sensors are not 1, which means not, you can see here not digital read. So all of these are not, which means all of them are reading a black line. So then we will move it forward. Similarly if digital only in this condition we can see that digital 1 2 and 3 are 0, and 5 and 6 are also 0, but the digital with the sensor 4 is 1. So here as a sensor 4 is on the right hand side of the centermost sensor, so it will nudge towards right, for which we will front motor, left front motor and right front motor will move forward. Our left back motor will run forward, and our right front motor will then decrease. We are decreasing its speed, and then again we will, so front motor is forward, left right left back and right back, all the four motors are forward, and then the right front speed has been delayed a bit, and then the left front speed is the same, and the right back's speed has also been decreased. So this means that both the right front and back motors are have a decreased speed, and the left motors have a high speed, so basically it will take a turn. So similarly we have created all the conditions here, all the possible conditions according to our logic, and we have created the motion of the motors accordingly. Now let's look at the code of the C language here. So in the C language again included all the necessary libraries and created the functions. The speed function is for the speed, and the speed A function is to let me so speed function is to set a PWM, set a speed which is basically whatever we will give it to it in the parameters, and the second one is also for the same but for the second motor, which means I mean that there are two motors. So speed is the speed function is for one motor, which varying the speed of one motor, and speed A is the function to vary the speed of the second motor. And similarly the function for motor stop, forward, right and left movement. So first of all we have this our main, where we have a while loop in which we are first setting all the directions of the pins according to our sensors and our L298 and ultrasonic sensor and everything. And then again all the conditions are, if conditions are created, and in them we are writing these whatever the function is to be performed. So now let me show you So we were looking at the functions of the motor, so let's go down a bit. So here, simple as speed, we have a speed function which will vary the speed of one of the motors. Here we can see our output pin, which is OC0A. We have used OC0A for the one motor and the OC0B for the second motor. Here we can see pin. We will be using PWM to control the speed. So here whatever the parent input we will be giving to this function, which is speed x, will be set, the value will be set to the OCR0A register. And here we have set all the settings of the TCCR0, all the settings and the prescaler and everything, set it into PWM mode and everything which is needed to run it, and according whatever the speed will be given, our motor will run accordingly to that. Here is the same code for the second motor. The only change will be the pin change. So now we are controlling with OC0B, so it is 85. All the other thing will be same. And motor stop, we are giving speed 0, which means basically 0 speed of one motor, and then the other motor's speed will be also become 0. So the motor will be stopped. When motor forward, both will go at a moderate speed, we can see here. And if we have to turn right, so one of the speed of one of the motors will be decreased, which is the left motor, and other motor's speed will increase. So this shift in speed will create a turning effect. Similarly done for the motor left turning. And all the conditions here we can see in the if conditions are created, and whatever the sensor senses, according to that the output is being generated by the motors, and the line following robot moves in that direction. Now after looking at the working of the first Arduino and the how the line following function is being performed, now let's move towards the interfacing. So first of all, let's go to the Arduino IDE code. These are some of the libraries that we included. We have downloaded from the open source internet platform GitHub, and we downloaded these libraries and users. So first of all, we have this ACSN12, which is for the current and voltage sensor. Then this liquid crystal I2C, which because we used I2C for the Arduino implementation, Arduino IDE implementation. So LCD was connected to the I2C, so we have a library for that, and the SD card library and the SPI communication library. So here we have defined the I2C's address and 16 pin. We have 16 pin I2C, and then we have here we have defined that at which pin we are connecting our sensor, and which kind of sensor it is. So 30 amp, we are a 30 amp sensor, current sensor. So we have described that, defined that, and then here are some of the calibration that is to be done for the sensor. So if there is any offset or anything, so it will be dealt with this sensor.calibrate function. And LCD, we are beginning the LCD and printing some, initializing the backlight and clearing the LCD. In the loop, we are continuously monitoring things. So first of all, we have a tachometer. We have connected it to the digital pin 6. So we have a if condition that if the pin 6 reads anything, so there will be increment in the counter variable, which will be 0. So we have a slotted disk in the motor. So whenever one of the slots pass the counter, the tachometer detects it and the change, and the counter variable is incremented. And we had 20 slots in our disk. So and one full rotation of the field made it travel like 21 centimeters. So basically we had 20 slots. So according to that, one slot was like 1.06 centimeter of distance. So we have calculated distance by multiplying the count variable to 1.06, which basically gives us the distance, that how much we have traveled. And if the digital read does not change, which means if it is on 1 and it continues to be on 1, then it will the code will stay here and it will not increment until there is a 0 again, and then again a 1. Then here we have the code for we are saving our current, get current, DC current from the voltage current sensor, and saving it into the I, variable which is basically for current, and then I've multiplied it with 100 so that I can get the reading in milliamps. So then for the voltage, we are simply reading from the A1 where the voltage sensor is connected, and we will be mapping it. So here is the we have a map function here. So whatever value is in the we have read, analog will be read, will be mapped from 0 till 1 0 2 3, and then we have divided by 100 so that we can get the answer in volts. Then to show the battery percentage, this is we had a 6 volt 6 yes, oh sorry, 9 volt battery. So according to that, if I had something like so my least amount of battery I could have was 6 volt, 6 to 9 volt. If the voltage gets less than 6 volts, the interfacing would not be it would be enough voltage to power up the robot. So which is basically the 0% of my battery, and 9 volts was the 100%. It couldn't go more than 9 volts. So for that we have subtracting the voltage that we receive by 6, we then divide by 0, which is basically means that if the anything between 6 to 9 volts will be taken out. Like if we have 7 volts, it will be become 1 volt, and when you will be divided by 3, it will become like 0.33. So this will basically like 33% battery. Then we have our SD card here. We have opened the SD card, we have created a file, and where we are storing this printing this health, battery, and the distance that is being traveled, and then we are closing. Then here we are displaying everything on the LCD here, and here again we are displaying from the LCD everything. So this is our basically our schematic for the PCB, and this is our PCB design. So first of all, let me go towards the C language code of the interfacing. So in the C language, for the C language code, schematic was a bit changed, the block diagram was a bit changed. So here we do not have an I2C, and we are directly connecting the LCD to the second Arduino, and here we were not in the C programming, we were given the exemption that we do not have to code for the SD card, we do not have to use it. So there is no SD card in this. We are basically just the code is basically just for current, voltage sensor, LCD, and the tachometer. So here again we have included all the libraries like interrupts, delay, IO, and LCD. This LCD library had to be created by our own, because the open source were for the 8-bit communication, and if you find a 4-bit communication that wasn't on the desired pins that we wanted it, we had to create our own library for that. And we have created some functions which are basically for taking the current and voltage value, and here again the count variable to count the distance, the slots of the slotted disk. And first of all, this is the interrupt we have, which is basically the interrupt for the tachometer. Whenever there will be a change in the value, then or basically a high to low switching, then there will be a count plus plus. Then the main, again we have given set all the directions, and created the set the settings of the external interrupt, which is basically for the tachometer. Then we have enabled all the interrupt, and initial is basically the function for the LCD to initialize. Then we are clearing the screen with this command, and then display the string battery, and then we are taking the voltage, shift down, which means we will be going down one space to of the LCD, displaying the current, and then displaying the number count for the distance. So here we have come to the function of the taking the voltage. So yes, here we are setting the analog to digital converter settings. So we have we have kept the voltage sensor at the A4 pin. So ADMUX has given the value, the fifth pin A5, so ADMUX has the value 4. Then we are starting the conversion. we are waiting for the conversion to finish start sorry, conversion to finish here, and then we clear the flag and whatever the we have two registers, ADCH and ADCL. So ADCH starts from are the last two bits of the 10-bit ADC conversion. So according to that, if ADCH is 1, then we add 256 to whatever the ADCL register value is, and if it's 2, then 5512, and if it's 3, then 768. Else the ADCL will be stored in the voltage variable, and we are dividing by 102 point multiply by 100 so that we can display the voltage value in volts. We are simply mapping it here basically. Then similarly we have the whole thing for the current sensor. The only change is that ADMUX will be now 05 because here we are connecting the current sensor at A6 analog 6. So all the other things remain same. And after creating this code, we have created the simulations for it. So here is the simulation for basically the working of the motor driver and everything. We couldn't yes, here again, and then this is the simulation. These are the simulations here for the whole schematic for the the robot, which was with the connectors and everything, which is needed for the PCB design. And here is the whole PCB design that was being made. Here we can see this is the first Arduino and this is the second Arduino. Here we have the sensors, ultrasonic sensor, L298, and tachometer and everything here, LCD. So this is a 3D view of our PCB design, and this is the actual robot. So you can see all the pictures of it, all the PCB design, it's etching. So after this we did all the assembly of the robot and the hardware implementation, and then we ran our code, and we were able to make a line following robot. Our line following robot worked with 6 sensors and all the interfacing that was required from the project. So now I'll be showing you a video in which you will be looking at hardware implementation of this project. So let me play it. So this is basically we were working our robot. Let me show you again. So here we are testing out our motors and with the PWM and motor driver and everything. Then this is our robot assembled breadboard. Here we are testing our LCD and displaying a simple character weave, that the library that we created with this is the C language implementation, we can see. And this is the our PCB design after etching. Then we are drilling it. This is the soldering of the PCB. Here we can see all the interfacing being displayed. Let me show you again. Here you can see on the LCD. And here on the LCD we can see, and then this is the robot, and this is finally the robot following the line. So that was all from our project.